Okay. First of all, let me congratulate you on taking the hardest and most important step, deciding to start. Welcome to the first episode of How to Make Any Games with Zero Experience in Godot. As your first game, we're going to create what's called a bullet hell game, where you control your character to dodge various patterns of attacks, similar to games like Enter the Gungeon. Now, I have to warn you, in this tutorial, you're not going to be simply copying and pasting the code on the screen. I'll be showing you my full process, carefully going over everything I'm thinking about. That way, you'll learn not only the ways to solve this specific problem we're facing, but also gain knowledge and building blocks that'll help you be creative with your own solution. And did I mention, you don't need any coding experience to follow along here. If you run into any questions or problem that you cannot find the answer to, I'm always checking the comments, so leave it down in the comments and I'll be happy to answer those questions. You know, one of the biggest questions I get all the time is how to get started on game development. Honestly, even I had to start somewhere. For me, it all began with bachelor's degree in computer science. That foundation taught me so much about programming and problem solving, which gave me the confidence to take on my own project and land my first job in the industry. And that's where Southern New Hampshire University, today's sponsor, can help you. SNHU offers an incredible game development program where you can earn bachelor's degree in game art or programming and development fully online. What's great is that SNHU is one of the largest accredited nonprofit online education providers in the country, and their tuition rates are some of the lowest nationwide. They're really focused on making education accessible. And that affordability is a huge benefit, especially if you're just starting out. The courses are taught by faculty with real-world experience, so you're not only getting hands-on knowledge, but also making connections with people who are also working in the game industry. And when it's finally time to find your first job, SNHU has resources to help you with that too. They even offer financial aid options, and if you have previous college credits, they may help you fast-track your degree. So if you're serious about building a career in game development and want a program that is designed to help you every step of the way, check out Southern New Hampshire University's game development program at snhu.edu/asthedev. This also helps the channel, so it's a win-win. Now, back to the tutorial. All right, so beginner's tutorial, that's where we're at. Reason I'm doing this is because, well, I don't know. If you have been following me, I have been releasing a bunch of different tutorials, different tool sets for Godot, and also devlog. I'm making games myself, and I've been doing a lot of things. You might not be a beginner. Maybe you have already an experience, but this could be a fun little refresher. Or you want to help out those other people who are joining us to learn, and you want to provide some feedback on this tutorial, provide further guidance. That's okay too. That can be fun. Now, I have been working on my roguelike deck builder tutorial that is different, right, than most tutorials. Because it's less of a tutorial, but more me working through a problem so that everyone can see the potential problems, the bugs, the difficulties that comes along with it, and how I go about solving that issue. The downside to that is, I do talk in detail about what I'm thinking about in terms of programmer mindset. But I also noticed that there were a lot of people who are struggling with some of the more basic fundamental things about programming and Godot. So I thought, hey, I think I should probably create a tutorial series that is geared towards the beginners. It's a follow along, but also kind of like a lecture in some sense, because what I want to achieve here is not only do I want to show you how to make games on Godot in general, I want you to learn how to program, how to think like a programmer, and I'm not going to skip any steps. I'm going to make sure I explain everything I know about any consideration that you might have so that you know exactly what to ask for if you need further questions. For example, if I say, hey, I'm using array here because I'm thinking about this things because array is implemented this way in a binary code, then you might be like, hey, all these things you said, I don't care about, but I am curious about what this means, and I can go further into that. Because I want all of y'all to have success in your game dev journey and achieve your goals and dream in making games, regardless of your experience. So let's do that. I'm going to build you up here fundamentally so that when you move on to the roguelike deck builder tutorial, everything will make perfect sense. That's the goal. Okay, so where should we start? I actually do not have any plan. I thought I'm gonna do this, so as usual, I do it raw. And the proof is in the pudding, so they say, right? One thing that I know for sure is that when you're getting started, getting something working fast and then building up from there is probably more satisfying. So we're going to try to do that. And obviously, there are a lot of documents out there, a lot of tutorial materials out there. So I'm not going to try to be too redundant, but we're going to make some things move. Let's see. Okay. I think a good place to start is top-down bullet hell. That sounds pretty fun, right? I mean, it's basically you got a bunch of bullets coming at you and you're supposed to move your characters to dodge the bullet. I mean, that's the type of game we're making. And that seems like that's pretty simple, but has a lot of the components of most games. You need to be able to control your character, but then you're not thinking about physics at all. You have the enemy or the hitbox of the bullet that you need to dodge, and then you might have different enemy characters that does different type of bullets, and then you can also work on upgrading your character. So there's a lot of things that is involved in bullet hell. So I think that's a great start. So let's make that a goal. We're gonna make a bullet hell. I suppose, alternatively, instead of calling this tutorial a beginner's tutorial, I guess I could call it, let's make a bullet hell in Godot. I don't know. Maybe that's a good idea. Okay, so let's just get started. I'm not going to do too much art or too much finagling. So let's create our project. So first thing you do when you open a Godot, I'm going to assume that you don't know Godot. Maybe you have created the project before, but you click create and you're gonna choose where the project is gonna live. For me, I have a directory called Godot project under my documents. There it is, Godot project. And then I'm gonna create a new folder here because I'm not gonna create it just here. I'm gonna create a new folder that says beginner bullet hell. And then I'm gonna select this and then also name the project My First Bullet Hell. Yeah, that's simple enough. Let's create an edit. Now, once again, I have no idea what I'm doing. I just assume that I know how to make things happen. I have never made a bullet hell before, but that's what I want to teach you guys, is that you don't need to have had the very specific experience of making the type of game you're making in order to be able to do it. You just need general building blocks in order to create what you want. Now, I don't have experience in 3D games, so I'm going to make a 2D game here. But in the future, I'm going to learn how to do 3D games so I can teach you guys that too. So here it is. Oh, I just went so quickly. Here, let me close this again. So when you open up the project first, you see this here as an option on the scene. And then this is your browser. So a few things. On the bottom left here, the file system is the files that exist in your project. And then the scene is where you put together a scene for your game, right? In a screen is a scene, and the scene has enemies, players, background images, all those things. We're going to create a 2D scene here. Boom, right? It created a no 2D. Now, you see this little star, meaning that it hasn't been saved yet. So first thing I'm going to do is I'm going to Control S to save. And I'm going to name this main scene, right? It's just main. I'm going to create a pattern here. I'm going to say all the scenes that I save as a file will be written in the format of camel case. Camel case is where if you have multiple words in a name, you capitalize the beginning of each name. So if I had main scene, it would be like main scene like that. But I'm just going to call it main. All right, we have our first 2D node scene. So the way Godot works is that you have a scene right here, and you can actually just start right now. Let's see. If I start right here by clicking on the top right, what it's asking is that, hey, well, you're about to play the game, and you have to select which scene is the opening scene for this game when you play this game. Right now, we only have one called main, so we're going to assign that, right? When you say select, it's going to just select this opened scene, or select current means you're going to select the scene that you're currently on. So it'll be main. If you have multiple scenes and you just wanted to select something else, then you just go to select and then you would browse and find a scene that you want to use as a starting scene. Simple enough. Cool. Empty, right? Nothing's there because I got nothing in the scene. So let's see. I'm going to keep this open. I could always stop it. But let me add some stuff here. So this is the root of the scene, and you can add stuff to it, right? And it's called a node. Each component is called a node. So we're gonna right click, add a child node, and you see these like various number of different types of nodes, right? They all serve certain function. They're very specific. And most likely, if you can't think of a node that does something, there exists a node for it, basically. So you rarely have to create your own pure version of it, but a lot of times you do have to customize a lot of things. All these things are very confusing. Sometimes the names of the nodes are self-explanatory. A lot of times nothing's wrong with just like clicking random ones and like experimenting with what they mean. Let's talk about the node structure, right? And I'm doing this because I'm trying to teach you how to explore this sandbox that is a game engine called Godot, figure out how to mess with it, right? So if you click on the node here, the first thing you will notice is that on the right bar, there's something called an inspector. So each node represents a entity, right? An object that exists in the game. If let's say you have a node called, I'm going to create a node that is a little bit more self-explanatory, right? So let's make a sprite 2D. So sprite 2D here. So this is a sprite 2D node. And sprite 2D node takes a texture. Texture is an image, another word for image. So let me, I'm going to just grab or create a real quick texture here. I'll make it 32 by 32. And I'm not even going to do anything complicated. I'm just going to make a little circle for the face, white dot for little smiley, and then maybe give it a little hair for characteristic. Let's say it's a little ghosty, right? It's a little Casper. I'm not going to worry too much about it. And then I'm going to save this guy back to my folder where I saved the project, which hopefully I remember. Mine specifically was on Godot project, and then I called it, what did I call it here? I called it beginner bullet hell, right? My first bullet hell in there. And then I'm going to create a character folder. You don't have to. I did it. And then say, this is going to be called player sprite. All right. I'm going to save it as PNG file. So now over here on their character folder, I have a sprite called player sprite. Oh, right. Because see, this is the nature of lecture style. So the node have something called properties. Properties define what the nodes, this particular node has. It defines the shape of this node, essentially, the characteristic of this node. So this is a sprite 2D, meaning this node is meant to represent a 2D sprite on the game. So right here, you can see some of the navigators here. This is when you want to move the node. So if I click on this move mode, which also is a W short key, you see that this node in particular gets this arrow indicating that you are allowed to move it. And you can see right here, I'm going to click on the offset and show you, or not offset, transform to show you that they're positioned currently as 0, 0. So if I move it, I can see that if I move it towards the right, the X is positive. If I move it towards the left, X is negative. If I go down, it's positive. If I go up, it's negative. Very self-explanatory. I'm going to just drag and drop the texture on there. Now you have the texture here. It looks blurry. I mentioned this in other things. So this is using, by default, what's called a linear. So it's like taking the average of the colors between. That's why it's looking all blurry. If you want it to look pixel perfect, which I often like to do, For the node, you can go to texture and then filter to nearest, meaning it doesn't do like a single pixel won't be present in 2 monitor pixels. It'll only be a snap to a single pixel nearest. Now, I don't want to do this on everything, every sprite I create. So I'm going to go over here. By the way, whenever you make changes in the property, you can see that this little circle thing pops up. This means there has been changed to a default value. So every node has a default value, meaning the value that it comes with to start. And when you make a change, it shows that, hey, you made a change on this property from the default value. And if I want to quickly go back to the original value, I just click on it and it goes back to what it was. So inherit often means, in this world of Godot, inherit always means inherit the property that's defined by its parent. So for example, in here, the sprite 2D is inheriting. That means if I go to the node 2D, which is a parent of this sprite 2D, and then say filter is nearest, then the sprite 2D also, because it's a child node of the parent node called node 2D, it'll have the same property. So that will make it so that everything that's under this root node will be nearest filter, which is great. That's one way to do it. Another way to do it, hold on, let me rename this real quick. Because I often like to rename the main or the root node of the scene to the same name as this file that it's saved as. Right now it's saved as main. So I'm going to slowly double click on the name to rename it, or you can right click and rename to name this. As you can see, the little star means it hasn't been saved yet, so I'm going to save it. Another way to, now that's per node. If I create another scene, then it's not going to have the property. So I'm going to go to the project. And I actually don't know where this is, so I'm just going to search for something called filter. And you can see they're setting under textures, and there's default texture filter nearest. So now everything in the project will by default have nearest as the filter option, which makes the pixel better. All right. So I opened this to show you the whole concept of, well, property. Each node has a property. Different node has different types of property. They're kind of self-explanatory a lot of times. You know, sometimes you don't know what they do, what they mean exactly. So this is an important point. Whenever you're unsure what they are and you want to know what they are doing, you can always right-click on any of these properties and do open documentation. And you can see the documentation for that specific node. And depending on, so for example, if I do centered, right-click, open documentation, it takes me to the centered of the sprite 2D class, right? And then it tells you exactly what they are. Now, it's technical, it's written in a technical way. So if you're not used to reading technical documentation, it might be a little difficult to understand, but eventually you will understand what they mean as you see more and more of these. At the end of the day, what's important is that you know it's there. Of course, when it opens the documentation this way, it opens it under the script tab. So this is a 2D tab, 3D tab for 3D scene, 2D tab for 2D scene. So you can edit the scene. Anytime you're editing script, you go to the script tab and you can go back and forth here. I know a lot of beginners sometimes get stuck here and I'm like, I don't know what to do. Well, you switch over to 2D here. All right, cool. Bunch of different things. I'm gonna try my best not to modify properties as much as I can, because I know more things I touch, more complicated this tutorial is gonna be. So we're gonna do as basic of a thing as possible, and you, in your own leisure, can experience or experiment with different properties and see what they do. But anyways, we got an image now. All right. Nothing. I'm not going to change anything. We put a sprite in there. We put an image. Let's see what that looks like. Now, I never closed the game, but you can see right there on the right top corner, do you see it? In that right top corner, you see a little bit of the sprite. It's because 0, 0 is top left. And right now, sprite is at 0, 0. So what if I move this a little bit? Let me move it down right. And you can see it's right here. Cool. Gone. In here. Nice. So that's what we have here. So the position, and you can see if you zoom out, you see this pink rectangle representing the size, the screen of the game. And of course, you can change this size, the project size, under the property. So if you go to project setting, and go to window, this is how you decide what the size of your game's resolution is. 1080p HD resolution is probably the normal stuff. That is what, like 1080 with is 1920, isn't it? 1920 by 1080, that's the typical HD. And there's a bunch of other options for setting up the window. Of course, once again, you can always look up these functionalities and the properties online. Once again, I'm not here to tell you exactly how to do everything. I'm here to equip you with the tools and concept where you can do further research, because we'll be here forever if we're to go over every single thing, right? All right, so if I play now, we see a little ghosty. Cool. And then now it's a full screen because I set it to 1080p. We want to be able to control this little guy, right? Now, there's many different ways to do it. There's a wrong way to do it and a right way to do it. There's a better way to do it and worse way to do it. Typically, there's a specific node called character body, and it's meant to be, look what it says, a 2D physics body specialized for characters moved by script. These are moved by script is basically script is where we are going to program to add functionalities to any of these nodes, and we want to make it so that characters move. So this is what people would use. How would you have known that if you didn't have the knowledge? You wouldn't have. But guess what? There's always an answer to it. Meaning, for example, right here, I have Sprite 2D. Let's do it the wrong way first, because it's actually in some weird ways simpler. So let's call this character. I'm going to get ahead and say this is the wrong way. But even the wrong way, if it works, right? So reason I'm showing you this is this. So the right way is always to find a node that is specifically serving your goal, right? For example, in this case, character body node. But sometimes you don't know what does, like which node does what, and sometimes your research doesn't land on that exact thing. But you know what you want to do. You know that if I press the key right now, I want this ghost body to move. That's all you want to do. So then you know you can just attach a script to this image and just move the image instead of treating it like all these fancy stuff. So I'm going to go from there, right? So if I right click on this node called character sprite and attach script, it pops up a little window to say, well, what is this script? And it automatically fills up this part, GD script, sprite 2D. It inherits, meaning this new script you're about to create is based off of other script, native base script. And in this case, because it is Sprite 2D, it has to inherit something to do with Sprite 2D, right? And right now, this is a character Sprite GD. It's already there. I'm going to just click on this right here to put it under character. So now it's under character folder, and I'm going to create. And ta-da, it extends Sprite 2D. This is the script. Let's look at some of the default functions. You define a function by typing func, and there's something called process, and then it takes delta as property. And this script is what's called a indent sensitive. So you define a function by writing func, writing the name of the function, and then defining what's called a parameter, meaning Do I have to go over what function is? Maybe we do. Like, I don't know how beginner we need to be here, but you know what? We're going to go over it quickly. A function is a group of code, right? Group of code lines that can be called immediately to do over and over again. So, for example, if I say, I'm going to create a function where, hey, move the character. Move the character. My purpose is that every time I want to move the character, I'm going to call, we're saying call, this function called move character and say X is something and Y is something, right? And then we're going to do a bunch of stuff here in here. And anytime I want to move this character outside of this script, I can be like, hey, like for example, over here, I'm going to just create a main script, for example. Like, I'm going to just be like, hey, oh, don't worry about this ready thing yet. But I can be like, hey, character sprite, dot, plus. When I do dot, it shows all the functions and properties that are available for that node, that object. We're just going to say, move character and say 2 to the right, and then 1 to the bottom, right? So this is called by this script here, and then would have called it. Cool. Well, anyways, so that's what function is. Function is basically a group of codes that you can call over and over again. Benefit of that is because there's a name that can be very specific to the function, that it's easier to organize and figure out what to do with it. And that also gives you a hint that whenever you are doing something, for example, self dot, you can see all these things. The dot p means property, meaning it's just a simple value. So centered here is true or false. Flip HG is also the true or false. And then F right here means it's a function to calls. And then this is called a signal right here, frame changed. That says something for the future. But anyways, what's important is that you're following along. So process is a default function that exists on every node. Every node. Well, you might be wondering, like, what is not a node? Well, there's something called object, and there's something called ref counted, resource. Those are not considered node, but it's okay. So conceptually, let's think about this conceptually. Conceptually, there are two main branches of, let's call it entity, or main types of class. We're gonna use the word class. Class is like a definition of a node or definition of a thing. It's like a blueprint. There's two types of main class. One is node. Node is physically represented in the game. It's actually added to the game, and then you can see it. That's not entirely true, but let's say, for example, that's the case. It's basically part of the game loop. And then there's something called data, right? Like the resource, the data aspect, which is, it doesn't really do anything as part of the game loop as the game is running, but it holds information. For example, player health. That's an information that doesn't have to do anything every tick of the game, but it's something that you need to define. So that would be something called something to be considered as data. Anyway, so every node that is represented in the game during the game loop has a function called a process. And process, this underscore process, is automatically executed once every whatever second. And this delta represents how many seconds has passed since last it was called. The process. When I say it, I mean the process. So let's just kind of test this out real quick, right? I'm just gonna say this is a pretty common way to debug by printing something. When you print something, so if I say something here, it prints that onto this tab called output here, right? So let's see. I'm gonna play this. I'm gonna save this, play it, and you'll see real quickly. Well, oh, whoops. I forgot that I made this mistake. Aha, my first mistake for the tutorial. This happens all the time. So what happened here is that I created this sample script called main script, and then I did this move character function for the character sprite as an example for showing you, but I deleted the function. So the function doesn't exist anymore. So then it's like, hey, let me show you the error. So this is a good example to show you how the error debugging is going to look like, right? It's saying, hey, character sprite move character, that does not exist. It says invalid call. So when you're trying to execute a function, it's called calling a function, right? So when you're calling that function called move character, it's saying it is invalid. I think this is a great exercise. Actually, this wasn't intentional. This was not intentional, but I think it's important to go over. So let's see how to read the bug. Invalid call means this call is not valid. Non-existent function called move character. So move character doesn't exist. Move character function doesn't exist in base sprite 2D. So it's saying, hey, I understand that this is sprite 2D because it probably looked at this right here, right? So it's saying, hey, this is a sprite 2D and sprite 2D doesn't have a function called move character. And I don't know what to do with that. So it's broken. So what I'm going to do here is I'm just going to make sure I delete all this. Anyway, so we're going to go back now. We're going to play it. It opens up. Ghost is still there. Or if you go back to this screen, you can see that right here. You see this? This is number of lines that are being printed out onto the output. There's 20,000 of them. It's crazy. But it's typing something out, because I said print something. And this is how many times the process is being executed. It's being executed over and over and over and over again. This is a good place to learn how to do breakpoint. So breakpoint is fun, actually. Whenever I have an issue, for example, like I said, hey, print something, but then it's not printing something. Like I wasn't seeing any property here. Right? So for example, if I set something like this, let's say I have a var is variable. So when I'm defining a variable is a kind of like a name that holds a value. So say test variable, I call this, and I assign it to false. And if I say, hey, if test variable, then print something, right? And I run this, what happens? I know most of you guys know coding, so I'm not going to like try to bombard you with this concept, but right here, it's saying, hey, nothing is being printed out. My output is empty. So I'm like, oh, what's going on here, right? And I can put a breakpoint, right? Boom. Right now, it decided to pause on this. So you can see there's an arrow. You can see that it's on here. It's on character sprite GD, which is this file, line number 5. And it paused at this point, and you can hover over these variables to see their values, right? It says test variable is false. So it's not printing because the test variable is false. And that's like, oh, whoa, oops, I forgot to change it to true. For example, I can say, bum, and then I can just resume by doing either clicking on this or doing F12. And then it comes back because it's running it again. Now it's true. And we're here. Another thing we can do is step over. Boom. It goes to the next line. It hasn't executed yet. It's just ready to execute this. But then you can see that the line, it has gone down to print something here. And then if I go to the next line or resume here, boom. I should see something printed. Beautiful. Okay, so that's breakpoint. Once again, for those of you who missed it, you set the breakpoint by clicking onto this part of the script left of the number, and it shows you the breakpoint. And let's say you set it up and you forgot where it was. You can go to the debugger, and I believe you should be able to see all the breakpoints down here. If you go to the debugger, you see where the breakpoints are, shows you the file name, line number, and you can just jump there and then just get rid of it if you don't want it anymore. Anyways, these are all the important tools that you will need to have, because I'm going to be like, hey, whenever you're asking, hey, Ezra, I haven't been able to do this part, blah, blah, blah. I'll be like, hey, can you put a breakpoint on this? And then you'll be like, oh, okay, boom. It's like, yeah, run it and then like do blah, blah, blah. and then you'll be able to do that. Okay, cool. Whew, I hope this is useful. I mean, okay, well, mid-check, is this too detailed? Maybe it is too detailed. I'm not going to try to make this tutorial too long, just in case there is a feedback from you guys where you want to say, hey, actually, I love this format, but then I want you to change this or that. I don't want you to be stuck here for 2 hours just watching me do this. So I'm going to send this out. I think my plan is to make this video, send it out, and publish it as a kind of like a tester and see where it goes from there. Take in all the rapid feedback, the things that you guys want to see more or less, and then I'll be able to change that and then publish the next video with more commitment, okay? Be sure to, having said that, be sure to like and subscribe and follow and leave a comment down below if you like it, if you don't like it, if you want to change something, whatever. Do that. So where were we? I'm going to remind myself and you, we want to move the character. There's a right way to do it, but we're about to do it the wrong way on purpose, and we are overriding process. So you know what's happening here. Process is something that checks every loop. And what I'm going to do is I'm just going to say, hey, like this character sprite I'm on, right? I'm changing the script of the character sprite. I'm going to say, you can access its own property by doing self dot, and then see that these are all the properties and functions that the sprite 2D that I'm working with has. And I can say position equals current position, right? Because it already has a value. At this point in time, in this loop, I want to add a little bit to the position. So I'm going to say position, which is type vector 2. Vector 2 is a pair of x and y value. So x, y, if we want to move it to the right, we want to add to the x, right? So I'm going to say, well, add to this position a vector 2, and it's going to add 1 and 0, meaning it's only going to go to right 1 pixel every time the process is executed. I know you already see some problem here, but that's not the point. The point is I want to see things happen incrementally and then make changes. What are we going to see here? Whoa, across the screen. Beautiful. I'm not controlling it, but I made it move. That's a progress. Okay. So now we know how to make things move. Now, one quick change and tip. You see how I said self in order to access my own, when I say my, I mean the script that I'm working on. I did self in order to access the property and functions of itself, right? The script that I'm working with. Actually, by default, it assumes that the self dot is included. So if I do something like this, instead of doing self dot, it'll do the basically same thing as doing a self here, if you just do position. And another quick trip, if you want to just add to the existing value, so instead of doing position equals position plus vector 2, you can always do position plus equals vector 2, 1, 0. What does that mean? Position equals itself plus vector. You can do the same by doing minus, and then it will be minus times divided. All those things work. But in this case, it's plus equals. And this is a good habit where whenever you make one major change, play it and test it to see that it's working still. Nothing's broken. Cool. Let's make a control, right? So we know how to move things. We know how to move it to the right. We know how to move it to the bottom. So let's do a input control. So we have if input action just pressed, and then UI right. For example, for those of you who know conditional already, don't worry about it, but I'm going to go over it really quickly. It's English, right? If these condition, if is a keyword that we use in programming called conditional. So if just means if the condition that is defined is true, then execute the next line, like the indented line, right? So you could have multiple things here. You could have print ABC, print EFG. And coincidentally, we're also doing a programming course here. But then, intention is that, hey, do you want to game develop in Godot without any programming experience, well, this is it. If you have a little bit of programming experience, this is still helpful. Don't go anywhere. Don't skip, because I like to think about talking about some of the more building blocks of the programming codes, like why if is if and why switch is switch and all that stuff. So you can see by indenting after if, I am telling the program that all of this is under the condition of if. And this will happen every time, right? So it comes over here. Let's think about this. When the line comes here, if this is true, whatever this is, it doesn't matter what this is. It could be like, oh, hey, if variable is true, or if that variable is false. Anyways, so if this condition is true, do this, then do this, then do this. And then come out of that if case and do this. What happens if it's not true? It's going to skip over all of this and then immediately execute number 9, right? So right here, look, let's do a little test. Print nothing. So if I press play, it's going to print nothing. None of these A, B, C, E, F, G is going to get printed. It's just keep going, right? I'm going to put a breakpoint here so it pauses when it gets in here. So I'm going to now use an arrow key to press right. Nothing happens. It didn't come in. So what happened here? So I did a UI right key thinking that this was going to come in here, but it didn't. Let me just test it one more time. Oh, it did, actually. It just didn't come to the pass. Pass doesn't do anything. So let me delete that real quick. So right here, A, B, C, D. Boop. So if I go to the next line, boom. It printed A, B, C. If I go to next line, boom. Printed E, F, G. Now it's back outside here and it goes nothing. Beautiful. Okay, so now we have an if case where if I do UI right, it comes in here. All right. So input is a kind of one of those like overall big keyword. And you can say, is action just pressed? UI left. So these are actually predefined words for this project and predefined input. There's something called input mapping where it associated. But for now, you just need to trust it. So you can say, is action just pressed? And then give it some predefined input mapping. So this one is UI right, UI left. And you can pretty much imagine what else we're going to have here. We're going to have this identical stuff for everything. Identical. I'm just copying and pasting, making sure the indentation is correct. We're going to have UI up. We're going to have UI down. And we know these are all going to be executed properly. We messed up something here, I think. We missed a double quote here. Right. So now you have this right, left, up, down. So what do we want to do? On right, when we press right, we want to get the position plus equals vector to 1 to the right. I'm going to copy and paste this. In this, I'm going to copy and paste everywhere. Left means -1. Up means up. Remember, in Godot, down is positive y. So up is negative y. And down is positive y. Beautiful. So I'm going to delete all this. Now we have a new script, and we're going to play it. We understand what that does, right? So now we have a little ghosty. I'm going to press right. Notice it's moving, but it's very slow. Also, something else is if you hold a key down, it doesn't do anything. You have to tap the key every time in order to make it move. Well, let's fix that. One, let's make it so that you can hold the key down. So key just pressed means within this loop. You see how the process, maybe the editor can draw some painting here. But basically, every certain second, a process is being executed. Process, 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 right? Action just pressed means before it hits the process, within this loop, that takes how many seconds? Within this cycle, was the key pressed? Meaning, if you hold it down, it pressed and it processed the event, but then on the next loop, it hasn't been pressed because you're just holding onto it. You're not pressing it. You pressed it in the past. So instead of doing just pressed, like just now, we just want to check if it is pressed at all. And there is a function for it called isActionPressed. So we're going to do that. And that way, much faster, right? Because it's not just calculating it once, it's doing it for every single loop. Cool. It's a little weird. But another thing, if you press the keys together, try top left together. Right now I'm pressing top left together. Boom. No diagonal movement. No diagonal movement. Just top left, bottom, and right. Because why? Because on every loop, it's just doing it for one of them. Because think about this. If I press right and up at the same time, it comes down here, it executes the right, it executes this. And the way if conditionals work is that once it's done with the conditional block, what we call a conditional block is a group of conditionals that are put together with if and elif, it's going to come out of that whole block altogether. So for example, if I do right and up, it's going to trigger this because it is pressing right. It comes in here and it executes it. And then now the block is done. So it's going to come out here instead of going to this, and checking as well. So we should consider this. We should separate these conditional into separate blocks so that it does its own processing. The way to do that is making it its own if block instead of elif. Elif is short for else if, meaning, hey, if the value is A, do this. If otherwise, do that. Right? It's a group. Do this or that. You're choosing do this or that, not both. Now we're making it a two separate, hey, do this if this. And then, yeah, do this as well if it is this. It's like making it a separate entity of block. We call it a conditional block, if block or whatever. So now it's going to execute for every button that's been pressed. So let's do that. Now I can move diagonally. I can do all of this. Beautiful. Cool. There's a shortcut here that makes this a lot shorter, but I'm not going to worry about that right now. We just want to make sure that this works fine, right? This is the wrong way. Remember, we're doing this the wrong way and there's a main reason why this is the wrong way. So later you'll find out you want to bump into things, for example, and there's something called collision. You bump into things, you want it to automatically stop and not move, meaning you can't control the position. You shouldn't be. This is a property that you're editing directly, right? Instead, you want to pass it off to some sort of physics engine to be like, hey, physics engine, like I want it to move that way with this force or this velocity. You decide where it should be. Right? Because if it runs into something, this physics engine needs to be like, yeah, you can't go anywhere. That's why this is the wrong way. But at the end of the day, fundamentally, like you can still work with this. And this is the beauty of understanding the fundamentals, right? Is that you know how to do things even though you don't fully know the engine. Otherwise, you're stuck trying to learn the engine altogether before being able to do anything, right? So just imagine I want to do spacebar and then it shoots or explodes or whatever. How would I do that? Any thoughts from what we have learned so far? Well, if you said do another conditional block, and because you don't want it to make it happen all the time while you're holding it, you want it to execute once per press, you want to use isActionJustPressed. And then what is associated to spacebar? We don't know yet. I'm going to tell you that it is UI accept, and then do some action here. Some sort of explosion, for example, right? And that would have worked. Okay, one last thing, and I think I'm gonna conclude this very specific tutorial because, as I said, I want to keep it short. I want to see how it's being received, and I want to see what people say about this. So we're just gonna stop it soon, but I do want to explain so that I can give everyone a little bit of kind of playground to play with. These action mapping, they're defined, and you can make your own under project, project setting, input map. This is where it lives, right? There's nothing here right now. Actually, if you flip this on, show built-in action, you can see all the built-in UI actions here. So you can see right here, UI select is spacebar, also joypad button 3, blah, blah, blah. Escape is UI cancel. So these are the actions that are associated with these input names. So for example, if I want to make my own, let's say I want to do W, I want the UI right to, or UI up to be W, for example. I can either search right here, or I can filter right here, UI up, and it shows up UI up here. It uses up, joypad button 11, D-pad up, blah, blah, blah. I'm going to go over here and then say add event. And it's right now listening for input. So if I make any input, it's going to populate it. So I'm just going to type W once. Boom. W is there. And I'm going to say, okay, now W is included. With that, now if I play the game again, if I press W, it's going to go up. Yeah, there you go. Cool. Another thing, I mean, you guys can figure out all of this. For example, this is too fast, right? I wanted to move some velocity, right? I can manually change 2 here, 2 here, 2 here. And then if I want to make it slower, I can do 0.5 here, 0.5 there. But this is tedious. And also, if you have a lot of objects, this becomes a problem. So what we as programmers do is we define a constant here, constant variable, meaning it's a fixed variable value that doesn't change. That's not meant to change during the gameplay. So a lot of the configurations, we define it as a const instead of var. So we could have done var speed equals, let's say 0.2, right? And then I can be like, oh, instead it's a speed minus speed here, and then if I press it, 0.2 is going to be applied, so it's going to be a lot slower. Cool. Also, if I change this to const, it does the same thing as of right now, right? Visually, nothing changes. Functionally, nothing changes. So why do we choose var, variable, versus constant? Constant variables are not allowed to change. Meaning, if I do speed equals 1 here as a constant, it's going to be like, hey, look, cannot assign a new value to a constant. Why is this useful? Why do we ever want a variable that we don't want to change? This is because error protection, right? Like sometimes you don't want to change a variable, or you don't want to programmatically edit a variable by mistake. That breaks the game entirely. Another reason is that actually there is a performance implication. The way underlying a compiler, what we call a compiler, is something that takes the code and turn it into a machine code. Historically, the constant variables are baked in. So they're more efficient in loading. I think. I mean, I need to check on that. I think that's pretty much what that is. Like it's slotted into a part of the memory as a value, and then we're not going to change it. So then it's like a little bit more efficient because it's baked into the drive as opposed to having to calculate it. Complicated stuff. We don't care about that right now. But essentially, rule of the thumb is if it's configuration, most of the time you want constant. Obviously, configuration you want to change by the user, then it should be variable. I would say that's a little different because you want to get it through files. Configuration should be through files. But that's story for another day. But for now, this is the movement. This is a kind of tutorial this will be. I know I talked a lot. I'm talking about a lot of the fundamental programming things. I'm talking about classes and all those things. Let me know if this is too much. So long story short, we did this the wrong way, but That's the point. That's the whole point. The whole point is that there is actually no wrong way to do it. There's just better ways to do things sometimes. But it's okay. As long as it works, it works. That's the, I guess, Developer Ezra's beginner tutorial series number 1, I guess. How to make sprites move wrong way. I don't know what to call this series so far, but I mean, let me know of any idea if you have it. And that's it. So I'll be back with longer video, something more fulfilling next time. But basically, this is the concept. This is kind of like a proof of concept. This is my demo, so to speak. So let me know how you feel about this series. Thanks for watching, and I'll talk to you later, I guess. I don't know. I'm not technically talking to you. Sometimes I'm live. You can ask me any questions there. I'm kind of looking forward to doing this. Otherwise, if you're way ahead of this and you are not suited for this type of audience, obviously I have roguelike deck builder tutorial. Also, if you don't need a tutorial, you just want to see other people just develop, I have a live development session every now and then, so you can see that. If you're a member, you get all the access to my past live broadcasts, so that's something to pass your time with. Otherwise, you can watch my dev vlogs on YouTube. So yes, I think that's it. All right, well, thanks for watching. I hope you have fun. I'll see you next time. Bye.